Our project for EECS 497 is called Euler's Eyes. Existing math practice websites don't well accommodate students with visual impairments. They're really often too cluttered for easy navigation and interpretation for someone with low vision. And they have really poor compatibility with screen readers. Often, these screen readers aren't even able to read the math on the screen because the math isn't encoded on the website in an accessible way. Euler's Eyes is a math practice website that's specifically designed for students with low or no vision. We imagined that our primary persona would be a student with visual impairments in middle school, high school, or undergrad who's looking for interactive math exercises to develop their problem-solving skills. The website can be fully navigated using just a screen reader. So students can listen to the screen reader's audio and move through all the elements in the website using just their keyboard. It's important that the user can navigate the website using just their keyboard because navigation designed with cursors in mind can be difficult for students with visual impairments. Here's what attempting some algebra problems may look like for a first-time user. First, they create an account with the website.
Voiceover on Chrome. Banner. Heading Level 1. Euler's Eyes. Heading Level 2. Master Math with Interactive Practice. Username. Username. Required make password. Required. Secure edit text. Login. Button. Link. Click here to create an account. You are currently on a link inside of web content. To click this link, press Control Option Space. To exit this web area. Website web content busy. Banner. Website web content busy. Heading level. Full name. Required menu pop-up. Edit text. You are currently on a text field inside of web content. To enter text in this field, A space G R E N green. Email. Required menu pop-up. A cider G E N at YAHOO Yahoo com. Password. Required. Secure edit text. You are currently on a text field inside of web content. To enter text in this field, type. This is a secure text field. Text typed into this field will not be displayed and will not be spoken by VoiceOver. To exit. Teacher. Role. Required menu pop-up collapsed button. You are currently on a button inside of web content. To display a list of options, press Control Option Space. To exit. Teacher. Menu item. You are currently on a menu item. To choose this menu item, press Control Option Student. You are currently on a menu item. To choose this menu item, press Control Option Space. To close this menu, Student. Role. Required menu pop-up collapsed button. You are currently Sign Up button. You are currently on a button inside of web content. To click this button, press Control Option Space. To exit this web area.
Once inside, the student can choose a particular category and topic of math to get exercises on.
Heading Level 1. Euler's Eyes. Heading Level 2. Master Math with Interactive Practice. Category. Empty Group. Algebra. Group. Pre-calculus. Group. Calculus. Group. Pre-calculus. Group. Algebra. Group. You are current Pre-calculus. Group. Calculus. Group. Topic. Empty Group. Equations. Group. Polynomials. Group. Equations. Group. You are currently on a group in Polynomials. Group.
Now notice, the screen reader will be able to read aloud the math problem for the student. The student will even be able to go back and listen to the math problem again. Then they'll be able to enter their answer, get the true answer printed so they can check their correctness, and then try another problem.
Natural log left parenthesis 5 over n product with I equals 1 underneath E superscript A right parenthesis group. You are currently on a math inside of them. Enter your answer. Edit text. You are currently on a text natural log left parenthesis 5 over n product with I equals 1 underneath E superscript A right parenthesis group. You are enter your answer. Enter your 2 5 25. You are currently answer button. You are currently on a button inside of web content. New question button 25. Empty group. New question button.
So, students can continue to try new problems for as long as they'd like to. Another thing that's great about Euler's Eyes is that it isn't just for students, it's also for teachers.
In this part of the video, we will be demonstrating the user scenario from a teacher's perspective. So a teacher can visit this site and see the login screen like normal, and then also click to create an account. And so we will sign up a teacher using the same fields as for a student, entering their full name, their email, which will then be used as their username, creating a password for them, and then selecting the teacher role out of the teacher and student options. So we will have them sign up. And then here you can see they are taken to a different home screen than a student, in which there are two modes, students and questions. So first we're going to have them select a question mode, in which they will come to this page and they have the option to add in some templated questions. So we can have them select a category. We'll choose algebra, and then for a topic we'll choose equations. So here in the question box, we have this blurb that says LaTeX format example, and then shows an example of how to format an equation. We chose to use LaTeX format for inputting our questions because it is widely known, and there's lots of documentation available on how to do it. So instead of having to follow a bunch of specific rules that apply to only our study for inputting in questions, they can just search up LaTeX documentation and they'll be able to find that. And additionally, LaTeX is very versatile and allows for teachers to submit pretty much any kind of math question. We're not limiting them to just simple math, as LaTeX has the capabilities to represent pretty much all types of math that are out there. And as you can see, some of these variables that I am typing in here in the question box are enclosed with the greater than, less than brackets in that style, and that is for our templated question functionality. That's how our backend knows that those are variables that they want to have templated. What that means is that the teacher can input in a templated question in this format, and they will be able to create multiple variations of the same question that have different numbers plugged in for all of the templated variables, which are the ones in those special brackets. And they can input them here into their answer using the similar style, so that our backend code knows that these are the variables we want to template. And as you could have seen before I clicked on it, there was a little blurb about how to input in the answer. And so the answer now is not in LaTeX format, just the only special formatting is for the templated variables, and that is because we use Python to determine the answer. So it does not have to be in LaTeX. You just have to signify which variables are templated. So then the teacher can click to add as many variables as they have templated in their question, and then we give a little blurb about the format for entering in these variables. And so it's just the templated variable as well as a minimum and a maximum for the range that you want to be plugged into these variables. And then our backend will randomly generate as many variations as they enter in here, with numbers in those ranges for those variables. So let's say they want 5 variations, they can then click submit. And then 5 variations of that question will be in our database and available to the students that are enrolled in their class. So now once they submit, it takes them back to this screen where they can enter in more questions if they want. But now we will be showing the student mode functionality. And so what that is here they can enter in the student's name to then add them to their class. So let's say the teacher wants to add in student 1. They can click add student, and then you can see that this now populates with the student's name, their username, and then this correct attempted column, which we will discuss later on in the video.
After the teacher has added their templated questions, Students will be able to access and solve the teacher's generated questions. If we navigate from algebra to equations, we'll see some questions in the same format as the templated questions from the previous teacher scenario. Because the teacher selected to have multiple versions of their questions created, the student will have multiple questions with this same format as seen here. This question is in the same format as the previous question, but with different numbers substituted in so that the student has more practice opportunities. The templated question and answer generator tool is convenient for teachers because it allows them to save time when finding or creating questions, while still providing their students with sufficient practice opportunities with the topics that they're learning. Next, we'll view the student's progress from the account of their teacher. After adding in templated questions, teachers will be able to see how their students are doing on the Students List and Progress page. Progress is reported as the number of questions the student has answered correctly and the number of questions that they have attempted so far. In this way, teachers can see whether their students have actually completed their assigned questions, as well as whether they have been struggling with the questions. This page is also navigable with a screen reader.
Level 1, Euler 9. You are currently heading Level 2, Master Math with Interactive Practice. You are Mode, Group Students, Button, Questions, Button, Student heading Level 1, Student List, Name, Strong, Username, Strong, Correct / Attempt, Student 1, Group. You are Student 1 at school.e5/5, Group, Student 2, Group, Student 2 at school.1.
Now we'll look at some technical details for the project.
We can look at it split into a front end and a back end. Our front end was primarily React JavaScript, which was useful just to get that interactivity and client-side dynamic pages to really get built and look nicer and flow nicer there. However, our primary focus was the MathJax library, which was really nice just because it could display the math, but even more so than that, there was accessibility features that made the math accessible for screen readers and also made it easy after a little bit of research and that we did beforehand. When MathJax gets embedded on the page, we took advantage specifically of one of the APIs that MathJax provides, which is native MML, which translates into MathMML or assistive ML. And when it does so, it basically includes a visual representation of the math directly from the LaTeX, and then a separate text representation from that MML or math markup language, which is hidden from sight or just hidden from displaying on the screen, but not actually from the screen readers, which can then hook onto there and then read that math markup language. So if you use things like JAWS, Mac VoiceOver, or NVDA, these screen readers can actually pick up on these, which is pretty cool. For our backend, we used Python and Flask, just because Python and Flask allowed us to really start prototyping and getting our product kind of working there, even though in production we could use better options. We used an SQL database for tracking user and question data, as well as all the connections between these two, things like students, who's teachers, what questions they've answered, and stuff like that. We also included a templated math system. So this was really cool and really fun to do because you can enter a LaTeX-based math question, you can place things in variable spots that you want to be replaced with these numbers that are randomly generated, and then you can generate those, and then you can also generate answers for these as well. So this was really cool and allowed us to do a lot, especially because you could evaluate the answers and then you'd have something to exactly compare against. So someone could answer 15 for a templated 12 plus 3, and it would actually match up, which is kind of awesome. However, there were a couple challenges that we dealt with. For one, our initial attempt for that text-to-speech was this LaTeX-to-speech pipeline, which takes LaTeX text into English speech. And so this is an AWS Poly-based solution developed by WWU, and it was really difficult to get working just because the project hasn't been supported in a while. But it's also kind of overkill at the current stage, just given that fact that it took us a while, but we did eventually figure out how we can just use MathJax and the native MML representation to kind of get those speech hooks there for us. We also kind of dealt with a couple of HTML and CSS issues just between browsers and how the screen reader really behaved. So this was a little bit to go around. Ultimately figured it out, and just styling was also kind of difficult. And then we also had some login flow issues. So things like password storage weren't things that we really thought about before. So we had to figure out how to encrypt and store those pretty neatly in Flash sessions as well. And then we also had student creation flows. So this, honestly, we could have planned out a little bit better, because once we got to actually developing it, there was a lot of different avenues that we try to go down and a lot of different rabbit holes, and ultimately just planning out, what it looks like when the students created, and then when a teacher's created, and then when the students connected to the teacher, and then when they add questions. We should have formalized that flow a little bit. So I think just even more project management skills there would have been particularly helpful. However, in conclusion, we are very happy with the progress that we've made in the current state of our project. If we had more time, we would like to implement LaTeX to Speech for some potentially visual and graphical questions, which would be pretty cool, just because MathJax probably can't do everything that we need there. We'd also like to implement a speech-to-text API to answer questions, which means that we could then answer questions with LaTeX answers, which would be really nice because those aren't easily comparable necessarily, and this abstraction might make that easier. And then finally, we could expand the project to more topics and beyond, so we can really take it to the next level and make it even more of an all-stop shop and just allow for more interactivity from the users. Overall, we're really happy with what we've done, and we would like to thank you for watching our presentation.